All right, welcome. Today, we're stepping into what we like to call the flow Tao Salon of statistics. This is where we look for the simple, elegant flow inside of all that complex data. And we're going to be decoding one of the most powerful numbers in the entire world of data science.
You know, you always wonder, does spending more on ads really lead to more sales? Do longer study hours actually guarantee better grades? How do we get past just a gut feeling and put a real, solid number on that relationship?
Well, say hello to the Pearson correlation coefficient, or as pretty much everyone calls it, just R. It's this one single number that captures the whole story of a relationship. It's simple, but it's also incredibly insightful. So let's dig in and see what this powerful little number is really telling us.
Okay, so this number R, it tells a two-part story. First, it tells you the direction of the relationship, and second, it tells you its strength. Let's start with direction. So first up is direction. If you have a positive R, it means that as one thing goes up, the other tends to go up too. Think about a baby's length and weight. They grow together. A negative R means they move in opposite directions. For example, the higher you go up a mountain, the lower the air pressure gets. And if R is 0, well, that means there's no linear relationship at all. It's like trying to connect the price of a car to the width of its windshield wipers. There's just nothing there. Now, the second part of the story is all about strength, and it's simple. The closer R gets to +1 or -1, the stronger that connection is. You can see here, anything over 0.5 is considered pretty strong, while the closer you get to 0, the weaker it becomes. But, just looking at the numbers doesn't really do it justice. It helps a lot to actually see it. The best way to really get what R is doing is to see it in action. So imagine you have a bunch of data points, and you draw one single straight line through them that best captures the trend. R is basically a measure of how neatly all those little dots are hugging that line. So if R is a perfect 1 or a perfect -1, all your data points fall exactly on that line. It's a perfect straight line relationship. Now, let's be real, you almost never see this in the messy real world, but it represents the ideal, a perfect connection.
Now, with a strong correlation, say something above 0.5, you can see the data points are clustered really tightly around the line. You don't have to squint or guess, the trend is just obvious.
In a weak correlation, though, the points are scattered all over the place, kind of like a loose cloud. Yeah, there might be a trend in there somewhere, but it's much, much harder to spot with any real confidence. And finally, when R is 0, or super close to it, it's just a total mess of dots. Trying to draw a straight line through this is pointless. There is no linear story to tell. So, knowing all of this, when is R actually the right tool for you to use? And that's a huge question, because R is a specialized tool. It is incredibly powerful, but if you use it in the wrong situation, you can get some seriously misleading results. So you absolutely have to know the rules of engagement.
Luckily, there is a pretty simple checklist. First, both variables have to be quantitative, meaning they're actual numbers, not categories like yes or no. Second, the data should ideally have a normal distribution, that classic bell curve shape. Third, you gotta watch out for extreme outliers, because one crazy data point can throw the whole thing off. And finally, and this one is the big one, Pearson's R only works if the relationship you're looking at is linear. It has to look like a straight line, not a curve. So what do you do if your data doesn't tick all these boxes? Let's say your data follows a curve, or you're working with ranks like first, second, third. Well then, you just need a different tool. And that's where something like Spearman's correlation comes into play, which is built for exactly those kinds of situations. All right, so let's pull all of this together. We're going to wrap this up with 3 key takeaways, and we're going to look at exactly why this stuff matters so much in fields like marketing and consumer research. Let's jump in. First up, R gives you this powerful at-a-glance summary. And in the business world, that is gold. It means you can get a quick, data-backed signal on whether 2 critical things, like how much you're spending on marketing and how much you're selling, or how satisfied your customers are and whether they come back, are actually moving together. Second. Okay, and this might be the single most important rule in all of statistics. Correlation does not equal causation. This number shows you a connection, but it tells you absolutely nothing about the why. For example, ice cream sales and crime rates are often highly correlated. Does eating ice cream make people commit crimes? Of course not. There's a hidden variable, hot weather, that's driving both. If you ignore this in marketing, you can make some huge and costly false assumptions about what actually drives your customers' behavior. And number 3.
It all comes down to this. Using the wrong tool on your data is like trying to use a hammer to turn a screw. It's just not going to work.
If you misuse Pearson's R on, let's say, skewed customer survey data that doesn't fit the rules, you could end up building your entire business strategy on a faulty foundation. And that can lead to some seriously flawed decisions and a whole lot of wasted money.
So when you boil it all down, it just comes back to this simple, elegant, but powerful idea. The Pearson correlation coefficient is one single number that tells you two crucial things: how strong a linear relationship is and which direction it's headed.
So, we'll leave you with this question to think about. Now that you've got this tool in your toolkit, what hidden relationships are you going to start looking for in your world?